The broadcast is now starting. All attendees are in listen-only mode.
Good morning, and thank you for joining us for another Ontario Concrete Paving webinar. Now, in our last webinar in January, we had Melissa Titherington from the MTO provide an overview of the new specification that the MTO has implemented to enhance the overall performance of their concrete pavements. Today, we are very lucky to have the Miller Group with us to talk about some of the projects they have completed recently using that new specification and some of the challenges that go along with achieving a next-generation concrete pavement. We do have two presenters today, one from the concrete side and one from the construction side, so the audience can see the overall process of what it takes to fully complete a provincial contract. But before we do get to that, my name is Alan Carey. I'm the Director of Technical Services at Concrete Ontario, and I will be your facilitator. And as always, my partner in crime, Tim Smith, the Senior Director from the Cement Association of Canada, is here as well. So good morning, Tim. How are you?
Good morning, Alan. Very good. Looking forward to the presentation.
Thank you. I am as well. And again, before we get to that, let's just talk about some of the housekeeping items for anybody new that's joining us. So we'll be approximately a 45-minute webinar. We will save all the questions and answers at the end. All participants are muted. So if you do have a question, just use the GoToWebinar questions pane on the right side of your screen and type in your question. And as mentioned, all questions will be answered at the end. The webinar is currently being recorded and will be posted on the Concrete Ontario website, and along with a copy of the PDF presentation that will be posted as well using the link below. If you have been missing any of our previous webinars, they have all been recorded and are posted on our website, so we do encourage all participants to check them out. We did start off with the municipal aspect, municipal concrete pavements. We just recently switched over to the provincial side to give you the overall picture. So again, if you haven't seen any of our previous webinars, we do encourage you to visit our website and look through some of the different case studies and introductions that we have done previously. Now, your presenters today, your first presenter will be Lucas Vanderplume, who's the General Manager for Miller Concrete East. Lucas and our other presenter will be introducing themselves, so it makes my life pretty easy today. And your second presenter will be Sammy Dawes, who's the project coordinator on the transportation infrastructure side with the Miller Group. So Sammy will be covering the construction process and everything that's involved when it comes to that aspect. So again, makes my life very easy today. So I will welcome Lucas and Sammy today. Good morning, guys. Thank you for joining us.
Morning, Alan.
We are quite excited. We are quite excited to have you guys today. Especially, we had a very successful turnout on our last webinar with Melissa in January. So it's great to get the other side, the contractor side of, how is the specification actually working out? What are some of the major challenges and improvements that could be made? So Lucas, I will turn it over to you first to introduce yourself and Sammy, and then we can move forward. So I'll give you controls here. There you go.
Perfect. All right. Thanks a lot, Alan. I really appreciate the opportunity to speak today. Since I've been working from home for the last couple of weeks, I realized that even though I like talking about concrete pavement quite a bit, my family does not like hearing about it. So I am looking forward to the discussion today and having a captive audience. So my name is Lucas Vanderplume. Like Alan said, I'm the general manager for the Miller Concrete East. So my responsibilities include our permanent GTA operations and our high production portable wet patch plant that we use to produce concrete for the large concrete paving projects. Although I primarily have management responsibilities now, my background is on the technical side. And I've been working with supplying concrete paving projects in some shape or form since I joined Miller Concrete in 2011. My counterpart on the placement and finishing side of the business is Sammy Dawes. I'll let him introduce himself.
Hi, everyone. Great to be here. My name is Sammy Dawes. I've been with Brennan for almost 9 years now, and I've been involved with concrete paving since the start of my career at Brennan. I've worked on some key projects here in Ontario. I've just finished the Highway 417 project a couple years ago in Ottawa. That was a 12-kilometer two-lane highway. Currently, I'm involved with the concrete base repairs at Highway 401, and I've also worked at CFB Trenton. We placed 150,000 square meters of concrete, and I'm excited about sharing some of my knowledge and experience with you in this webinar. Thanks.
Awesome. Thanks, Sammy. So Sammy and I work for Miller Paving. We're a large construction and materials supply company operating primarily in Ontario. In 2018, we were bought by Colas SA, who's a big multinational construction materials supply company based in Paris, France, just to give you a bit of a background of where we're coming from. So here's a quick overview of what we're going to be talking about today. We broke in the presentation up into two sections, kind of divided along our separation of duties. So I'm going to talk about the production side of things. I want to talk about the specifications and materials, plant setup, and daily operations. And then Sammy's going to take over and he's going to introduce some of the placement and finishing parts of the job, which he's going to talk about some paving equipment, paving quality, and some of the current challenges that we have with the new MTO specification. So the first spot to start is with your specifications and materials. Aggregates are the biggest volume piece. They're the biggest mass piece of any concrete mix design. That's usually the spot that we start when we're looking for, bidding a job and starting a new project. There's a couple specific things about concrete aggregates that are different from your normal structural materials. The first one is the size. You're always looking with concrete pavement to be using a larger aggregate. So you got that 37.5 mil stone. Not all producers have big stockpiles of this material. It's pretty specific to concrete paving and a couple other kind of niche applications. The other big one we got to talk about is D-line cracking. A lot of, it's basically a freeze-thaw damage that's specific to concrete pavements. It's not a test that's required for normal structural aggregates, so a lot of producers don't have that data handy unless they are specifically concrete pavement producers. They're on the MTO DSM or the approved sources list, and they maintain the test data that's necessary to be able to supply those projects. So that can limit some of your material sources. And then the other big one we want to talk about is the fine aggregates. You got to be really conscious of the siliceous content if you're going to have a if you're producing like a running course finished concrete pavement. You got to have that 60% minimum acid insoluble residue. So depending on where you're working in the province, some sand pits, some sand sources have higher carbonate contents than others, and they may fall under that 60% insoluble residue. So you have to be really conscious of that, and that's a concrete pavement specific specification that not all producers have data handy. The next thing we're going to talk about is cements and supplementaries. Pretty simple. You're basically making the decision between using type GU or type GUL, or combining supplementary. So either a fly ash or a blast furnace slag. In Ontario, there's not a lot of fly ash available. There's no coal burning plants anymore, so it's pretty well exclusively a slag market. And when you're doing the new specification with the MTO concrete pavements, there's now a permeability requirement, which basically necessitates that you use some form of supplementary cementing materials. So pretty well all paving on concrete paving projects going forward are going to be some combination of GU, GUL, and slag. And then the admixtures are super simple. Concrete paving is a very basic admixture application. Usually you have a type A water reducer or a type B and D water reducing set retarding admixture, and your air entraining admixture. And the air entraining admixtures are usually concrete paving specific. The material is produced at a really low slump, which makes it more difficult to entrain air. It's usually done through a central mix plant, which means there's a very short mixing time. So you need an air that can be generated really quickly at a low slump and then remain stable through the really heavy vibration that's applied with the concrete paver. So there's specific chemicals that are used for that, and they work extremely well. So that's usually not a major problem. Now, when we talk about performance requirements, historically looking at concrete paving, there's a 30 MTO or 30 MPa compressive strength design, very simple. But with the recent change in the specification to add the permeability, the design criteria has moved towards the permeability rather than the strength. The water cement ratio required to meet those permeability specifications is usually lower than it would be required to hit that strength. So that's really become the defining characteristic for designing a mixed design. And that also requires the supplementary cementing materials, like I mentioned, usually 25 to 30% replacement with slag. The air content is pretty straightforward. Minimum 3%, spacing factor of maximum 230, same as normal concrete. So there's nothing too exciting there. It's all done, all the testing on these MTO contracts is done on in-place material, which is a little bit unique. It introduces a little bit more variability with the placing and curing. But at the end of the day, I think it's a good thing for the concrete pavements because you end up with a product that is, you end up with test results that are more representative of what the actual in-place material is. So even though it's a little bit more variable and a little bit more difficult to design, I think it does really provide a better product at the end of the day. And then the last thing that is really important in performance requirements that we don't is really difficult to quantify are the consistency and the placeability and some of those constructability factors. You got to be able to design a mix that meets those permeability requirements, has very low water cement ratio, but also has enough paste content and is workable enough for the contractor to be able to place it consistently, give it a really, smooth finish, good ride quality, control the edge slump. You have to have it a really consistent slump content so that they can dial in the machine and produce a road that is really consistent. If you have good consistent inputs, it's easy to have good consistent outputs. If it's a variable input, it's going to produce a variable output. So making sure that you have a mix design that is easy to produce and easy to place and finish is really, really important. Almost as important as the permeability and the strength in the air and all those other things. The last thing we'll talk about with the specs and the materials is the testing. The big one on the raw materials is the aggregates. We moved to a new aggregate specification, which is a lot more demanding than the previous ones. They're pretty small lot sizes, 10,000 square meters, which during high production on paving can be 3, 4, maybe 5 samples per week. So they're taken during production, which is definitely a challenge because when you're producing that fast, there's a lot of activity around those stockpiles. So making sure that everybody is safe and out of the way of the production is really important. The other big change from the previous specification to the new one is going from a $1 per meter penalty to a total rejectable clause, which makes it. It really shows that there's a focus on making sure the material goes into the pavement is 100% compliant, and it puts a big focus on the producers and the aggregate producers to make sure we're testing the material at the source, we're testing the material again at the plant. We're using really big stockpiles that we can confirm gradations as we're building the piles, and we can be really, really certain that everything that goes into the stockpiles is in spec. And then when it comes from the stockpile into the plant, everything is in spec the whole process along to eliminate any potential for surprises with the QA sampling during the process. And then cement and aggregates or cement and admixtures are pretty straightforward. Usually taken at the beginning of the contract, and if the contract's big enough, there'll be a couple other samples throughout. But they come from big, very tightly controlled production facilities, and there doesn't tend to be a lot of variance in the test results of those products. The plastic concrete is very similar to normal. We test the first 5 loads and then every 5th. When you're producing at a really high rate, loads every 2 to 3 minutes, you need to have really strong technicians there, guys who are familiar with this sort of work and can keep up with that process and do the tests quickly and efficiently, because you can't have you can't have that being a hold up in your production. So, and then being in really close contact with the plant and identifying the trends and making sure that you're making the adjustments on the trends. So if you see the air's creeping up or creeping down, the slumps are changing, making the adjustments with the plant and the mix design to make sure that you get good, consistent results at the front of the paver. And then the hardened concrete's going to be air voids, RCP, and strength and thickness cylinders taken. I think the lots are every 500 cubic meters. So on a busy day, that would be, I mean, that's typical for based on a thickness of 250, 250 mils. So that'd be 3 to 4 tests per day, sets of tests per day on a big production day. But so once we kind of know what we're going to be producing and what we're going to be producing it with, we get into the fun part, which actually setting up the concrete plant. We have some basic requirements for a site. What I like to see is about 3 acres. I think that's really the minimum for what you would want to have to be able to control the traffic flow and put up the size of stockpiles that you want to have to really create that consistency and really make sure that you can manage any segregation within the piles and put up a big pile in advance of production so that you can get all your gradation testing done in advance so that you are very confident in those materials. It's got to be a flat and level site. You're using a lot of dump trailers, so everything's got to be flat and level and preferably on solid ground. And then the last thing to consider is your environmental restrictions. These concrete plants are really busy sites. They're loud, they're dusty. They're not nice to your neighbors, so you want to make sure you have lots of setback between the plant location and the neighbors. Every plant is going to have its own unique setback requirements. The best case scenario is to be right on the job site. If there's space within the contract limits, that's the best thing to do. You're closest to the point of placement is just going to ensure the highest quality and the most consistent supply. The access requirement is really important. You got to have good one-way traffic flow. You want to be able to keep your cement tankers separate from your aggregate trucks, separate from water trucks if you're bringing in water, and you want your concrete trucks on the other side of the plant. Usually, so you have your raw materials flowing in on the back side and your concrete product flowing out on the front side. So you have your usually hauled with dump trucks. So you have a washout pit that's at the front side of the plant where the guys can wash the boxes out after every load, maybe 2 loads if the weather's cool. But you want to make sure that there's no hardened concrete building up in the corners of the boxes or around the top of the box. So the trucks are in there washing out every load and then coming under the load point. You want all that in front of the plant so the operator can see everything that's going on, and you need to have a big staging area for those trucks to all be backed up. Because that mixer, we want it to be tipping every 2, 3, 4 minutes max. So you need to have those trucks lined up, because as soon as the mixer returns into the cradle, there should be material flowing into it, which means as soon as the truck pulls out, you need the next one coming under right away. And touch on the stockpile. When we're going with big high production numbers like that, you need to have big piles. You want to have lots of residence time on the ground, so that the moisture content of the material can homogenize throughout the pile. And then as the loader is eating into the pile, you don't get big fluctuations in your moisture content and in your water content. So the batcher has an easy time producing really smooth, consistent concrete. And you want to have a good solid base under the stockpile area. Paving is the best thing you can do. Just make sure the loader's got a nice clean way of scraping up the piles without getting into anything underneath it, and it'll minimize your stockpile losses at the end of the project as well. And then the last thing you got to think about is what equipment are you going to use for the project. If it's a big high production facility, you need to have a wet batch plant, and the volume is really going to justify whether you use a generator, you hook up to the local hydro grid. Where's your water coming from? Is the project big enough to justify putting in a well? Is there a fire hydrant or a water line that you can connect to? Are you going to be trucking it in from a local municipality? A lot of these projects are in rural areas, so wells or truck water are usually the main sources. And then additional cement storage is a big consideration as well. You can see the silo that's going up in that picture. I mean, that's a pretty big silo for a portable concrete plant, and it's not nearly big enough to hold all the cement that you need for the production rates that we're doing. So usually what we'll do is put in some horizontal storage silos on the ground, like cement pigs, and they can hold, 3 or 4 loads. That silo there would hold maybe 1.5 to 2 loads. So you need to have the storage on the ground to be able to supplement that overhead silo. And then on the day-to-day production, it really depends on what you're going to be doing on that day. I mean, there's always going to be some handwork and patches, filling in pieces that, couldn't get got to or couldn't get placed by one of the paving machines. So, there's cores and tapers and things like that, or stops and starts and patches and things. That's usually done with ready mix trucks. So usually pretty slow days, not too much to worry about on the production side of things. And then when we get into some other areas, maybe turning lanes and merge ramps and that, they'll do a lot of single lane work, usually done either with dump trucks or ready mix trucks, depending on the access and what equipment's available on site. It'd be pretty typical of a normal ready mix production day, 300, 400, 500 meters, nothing particularly exciting. Usually a good opportunity to get a little bit of maintenance and cleaning done on the plant while we're between loads and while we're waiting. There's not a lot of demand on the production side for those days. And then the real exciting stuff is when we get into feeding the big two lane machines, and that's where the production rates start getting up there a little bit higher, 150, sometimes 200 meters an hour, depending on exactly what the application and thickness and width and all that are. So the big bottlenecks that that's when we have to start looking for the bottlenecks in the production side of things. Tankers, the cement tankers can be a big one. When we're consuming at 200 meters an hour, we'll be chewing through cement, more than 60 tons an hour. So if you've got a cement tanker that's blowing at 20 to 30 tons an hour, you need to have 2 or 3 tankers hooked up and discharging their cement at the same time. You need to have your aggregate guys coming and going. You make sure your loader is big enough to move the amount of material that you need. I mean, if you're doing 200 meters an hour, that's north of 400 tons an hour. So you need a big piece of equipment to move that much material, and that's both stockpiling and feeding the plant at the same time. So quite often there'll be a smaller piece of equipment close by that can help supplement if it does get behind. And then you got to have enough haul trucks to move that much material out of the plant to the paver. Depends how far away the machine is from the concrete plant, how many trucks you'll need. And keeping the operator focused for that period of time, it's a really, really detailed job, watching every single one of those loads and getting them stacked up and making sure they're all produced to the exact specifications and making sure that the plant is running. Everything has to be going, 100% to be able to hit those. Production cycle time theoretically is, 2 minutes per load. Basically weighing and discharging the scales in a minute and then mixing for a minute in the mixer and putting it into the load. So having the operator be able to focus and pay attention to things that quickly is a big challenge. You need an experienced guy who knows what he's doing. And then moisture control is probably the biggest critical factor. I think monitoring the water content and the slump control so that it's consistent going to the paver so that the paver can spread the material out as smoothly and quickly as possible is really, really important. And that really comes from having big stockpiles, lots of residence time, and an operator who knows what he's doing. So I got one quick. These are just a summary of some of our test results from our most recent project. You can see it's a really, really high compressive strength and very low permeability. It's a really efficient mix. I think the biggest benefit here was that we had that paving plant right beside the concrete paver, right beside the road. So very, very short times between production and placement. And I think for that reason, that's very one of the biggest reasons why you see these really high compressive strengths and these very low permeabilities. And then strong spacing factors and hardened air contents too. So we did end up with what I think is a very high quality concrete in the road there. So yeah, that's pretty well everything I have to say from the production side. I'm welcome to listen to Sammy for what happens on the placement side.
Sammy,
Awesome. Thanks, Lucas. Yep.
Okay, go ahead. Thank you.
Perfect. Thanks, Lucas. Okay, I'd like to start by introducing some of our paving equipment. From the placement point of view, we rely heavily on our equipment and the know-how and experience of our workers. So for that reason, I'd like to start introducing our equipment and then move on and talk a little bit about quality and some of the challenges we're currently facing. So one of our main pieces of equipment is the Gumaco 2-lane paver. This piece of equipment is capable of placing large volumes of concrete in one shift. We've seen days where we place 2,000 cubic meters in a shift, which is a lot of concrete. One other great advantage of this paver is that it has an integrated dowel bar inserter in it. And what that gives us is flexibility when paving. So let's say there's a grading operation going on and the grade is ready today. We can jump and start paving tomorrow. Whereas if it didn't have the dowel bar inserter, we will have to wait and lay all the baskets down, and takes more time. So it gives us more flexibility with the schedule. Another great advantage for having this machine is the quality of the work that it produces. Ride quality, from my experience, the best ride quality I've seen was from the 2-lane paver, more than the single lane and more than the handwork. And also concrete consolidation. For machine paving, from my experience, concrete consolidation was consistently excellent. Now, this is a big piece of equipment, and one of the disadvantages or one of the major challenges it imposes on us is the time it takes to change the width of the machine. So let's say we got a 10-kilometer highway where half of it is 8 meters wide and the other half is 9 meters wide. We're gonna need 2 weeks in between just to change the width of the machine. And as you can imagine, that would put a lot of pressure on the schedule to stop everything and take 2 weeks just to change the width. But but it also comes with its advantages of being able to place a lot of concrete in a day. So another important piece of equipment that we have is the single lane paver. A great advantage of this paver is the ease of transport and relative ease of changing its width. We can change the width in a day. It's a lot easier to transport and set up. And at the same time, it's still capable of producing large volumes of concrete when we compare it to hand-placed concrete. And also it has great consolidation and improved ride quality when we compare it to hand-placed concrete. So it's still a very capable machine. Well, one obvious disadvantage is the amount of volume that it can place in a day. It's a lot less than the 2-lane paver, and we need to lay out load transfer devices ahead of the machine, and that adds one more operation to the, one more task to the operation, and could make it slower and a bit more challenging. But it's still a great advantage to have this machine. Just to give you a quick overview of how much concrete we can place or what we're capable of placing. The single lane paver, we've placed anywhere between 300 meters to 450 linear meters in a shaft, like 300 to 450 meters of a single highway lane, which is quite a bit. And for the two-lane paver, we've done anywhere between 700 to 800 linear meters per day of a two-lane highway, which is also huge. So one big factor that affects productivity is concrete supply. So for a single-lane paving job, truck access is very important to be able to get the trucks in and out quickly and offload them. And for the two-lane paver, I would say it's almost impossible to do it without a mobile plant that can supply you large volume on site and give you a consistent concrete mix. So for the two-lane paver, we almost always need to have a concrete plant on site to supply the volume we need to be productive. Now I'd like to move on and talk a little bit about quality. Right quality is a very important aspect of concrete paving and highway paving. Like I said, our two-lane paver, from my experience, was the most capable of delivering high ride quality. And just to give you an example, in the recent project we had at Highway 417, we were able to achieve an average IRI of 0.93 meters per kilometer, which is very comparable to asphalt. We did do grinding. We ground about 30% of the job, but given how stringent the new spec is in terms of ride quality, and that we're able to achieve ride quality that's comparable to asphalt with 30% diamond grinding, I think that's a big testimony to the capability of the machine, and to be honest, the capability of our crew of placing quality concrete. Now, I noticed there are a few design factors that can improve ride quality or puts us at a disadvantage. Of course, you can grind everything, but the road profile plays a big factor. So what I found is wherever we have horizontal curves, so whenever we transition from full super elevation to full crown, we do most of the grinding in these areas. And also wherever we have vertical curves, like if we're going uphill or if we're going downhill, that's where we have to do most of our ride quality correction with diamond grinding. Other factors are the string line accuracy. This machine follows a string line for paving and needs to be accurate. And the machine itself needs to be well maintained to track the string line accurately. Another important quality aspect of concrete paving is being able to maintain a constant thickness of the concrete. So an important way to achieve that, there are different factors to achieve it. One important factor is the slump of the concrete that we get. Edge slump is important. So if you can imagine, if we're paving wet concrete, wet concrete, the slump is gonna force the edge of the slab down. It's gonna sag, so which would affect both ride quality and thickness. And fortunately, from our experience, we're able to get from the concrete plant consistent slump concrete that's consistently dry. And one of our airport projects, we're able to consistently achieve a 3 millimeter edge slump when we paved 350 millimeter thick concrete. So you can imagine a foot thick concrete that only slumped down less than 3 millimeters, which is huge, in my opinion. And the other thing that controls thickness is the string line. If you set the string line to the right elevation, and if the grade underneath the concrete is good, and now with equipment you can grade it within 10 mils. So thickness has not been an issue from my experience on most of our projects. We can control thickness to a large degree. Another important aspect is concrete consolidation. As you can see, that's a core taken from one of our projects. And to give you an example, at Highway 417, it was a 12-kilometer highway. We took 500 cores for different tests for compressive strength and thickness and AVS and RCP, you name it. And almost all of these cores had excellent consolidation. I remember seeing a single core where there was major segregation or major issues with consolidation. So I think that's all I got to say for now about quality. Now, all the capability that we have, the equipment and the know-how, is not without challenges. And some of the current challenges that we're facing now is large volumes and large areas and large quantities of highway repairs that we have to do on weekends. Now, where's the challenge with this? You know, if we're talking about 2 weekends or 3 weekends where we have to, excuse me, you know, if we're talking about 2 weekends or 3 weekends where we have to shut down the highway, remove the concrete and repave, I would say this is manageable. But sometimes, say last year, we had over 10 weekends to do on the 401, where, you know, you'd close the highway or the lane completely, remove the concrete, regrade, place load transfer devices, and pave in a single weekend. Now, where the challenge is, the concrete that we need to use is high early strength concrete, and high early strength concrete doesn't react well with high heat. So now we're trying to plan our weekend paving operation, and in addition to everything else, we're looking for rain. You know, like if there's a major rain event, we can't pave. And now we're also looking for temperatures. And, you know, if it's August or July and, you know, we're looking at 35-degree temperature, we also can't pave because, you know, there were times where we experienced the concrete hardening inside the paver. You know, we're using a 10-hour mix, we're paving, the paver is hot, the weather is hot, and the concrete is just drying up inside the paver, and that was just a complete nightmare. So what happens if we have a lot of weekends and a very limited window to pave? That puts a big strain on the schedule. And then when do you find the perfect weekend where there's no rain, where the temperature is cool enough and everything's in place, all the suppliers, all the trucks, everything you need is in place to do it? It's doable, but the sheer amount of the area that we have to cover just makes the timing of it the challenge, is that you have to get it done on a weekend. And there are so many weekends with good weather in a year. So that's one of the major challenges that we have. And another major challenge is the new spec. Sorry, I skipped. Is the new spec. Now, there's a lot of things I like about the new spec, like the grooving looks great in the new spec compared to grooving in plastic concrete. But there's also big challenges in it. One of the major challenges is joint sealing. With the new spec, the maximum width you're allowed for the transverse and longitudinal joints to seal is 6 millimeters. And now we are required to seal the full depth of the joint. So there's no more backer rod, no more wide joint. You do your relief cut 1/3 of the way. So, on a typical highway, that's 80 millimeters deep. And now you have a joint that's 80 mils deep, 6 millimeters wide, that has to be perfectly clean, and you have to seal it in a timely manner. Now, I'll just give you an idea of how slow it is to seal these joints. Before the Highway 417 was the first project with the new spec. And, we're talking to subcontractors and they can tell us, oh yeah, we can do 2,000 meters of joint sealing in a day. Well, that's the old spec. Now, the new spec we can only seal 700 meters a day. And I took a picture of the nozzle that we used to seal. I don't know if you see that little metal piece. This is almost doing caulking on a joint for a 12-kilometer highway. So you can imagine how slow this operation is. And we already have a short construction season. And now, if that alone is not a challenge, now let's think about the new smoothness requirements and the new diamond and the new grooving requirements. So we have tight joints to seal that are very slow, and we have a very stringent ride quality spec, which we have to do more diamond grinding, and we have a new grooving spec where it has to be done by machine. So what this does is, when you place your concrete, in the past, you can tine it with a tining comb, and you don't have to bring a grooving equipment. Joint sealing was a lot quicker, and the right quality spec was a lot more forgiving, so you didn't have to do as much diamond grinding. So now you place the concrete, we have to do more diamond grinding. We still have, which is done by a subcontractor most of the time. We have to do grooving, which is done by a subcontractor. So now you have to find when your subcontractor is available to come in and do your grinding and grooving for you, right? Because they have other commitment, and there isn't a lot of grinding and grooving equipment in Ontario. So that adds to your schedule. And also, you need more than one crew to do your joint sealing to catch up. And because it's a new spec, a lot of subcontractors don't have experience with this joint sealing, and a lot of them don't want to do the work. So you're restricted with how many joint sealing crews you can put on site, and your season is shortened because now after you place the concrete, you have to groove it and you have to grind it more, and you have to rely on an outside subcontractor that might not be available when you need that sub. So it just adds more time to your paving schedule. So these are just two of the challenges that are recent, and I'd like to share with you. And I think that's the end of my presentation. If anyone has any questions.
Great, thank you, Sammy. We will take some questions. Some did come in as you guys were talking. So the first question, obviously there's a lot of challenges when it comes to the new specifications, and you just highlighted one of the biggest problems. Are there any suggestions about how you could change the specification to make the life easier for you when it comes to the joint sealing?
Yeah, I mean, to me, the challenge is the time. So we need temperature to do the joint sealing, and the solution is maybe revise the joint sealing method, maybe revert back to the old joint sealing method, or come up with a new joint sealing method or new joint configuration that has two aspects to it. One, we need the contractors. We need a big number of contractors to be able to do the work. So I think whatever configuration we need to come up with, I think that needs to come from, we need input from the big joint sealing contractors in Ontario, because now you're reaching to contractors and they just simply don't want to do it. So I think we want to reach to joint sealing contractors, I know the old joint sealing spec, most of contractors in Ontario know how to do it, and most of them know how long it takes to get it done, and it hasn't been challenging in terms of time. You're falling behind, you can call another contractor to come and supplement your crew. But with the new spec, it's like the challenge is the shape of the joint. It's you're restricted by how much fluid you can put in that joint, and with that small nozzle, you can only place so much. Yeah. Period. So that's why I think the shape of the joint is a huge factor.
Makes sense.
Makes it very.
Yep. Thank you. Makes sense. Another question, I guess follow-up question. In your experience, are some of these requirements warranted? Some of these new requirements, like changing the reason they changed the joint layout was because we were seeing a lot of deficiencies, especially in the 417. Now, do you believe that some of these changes are warranted going down to this type of joint detail?
If I want to look at the 407, it was built in the 90s, and in my opinion, for the past couple of years, we've been doing grinding and grooving on the 407, so I'm very familiar with how it looks, and I'll be honest with you, it still looks beautiful, and I think they sealed it with I measured the joint. It was the old joint seal, so maybe there's a lot of different factors when it comes to concrete longevity. Like the subgrade is important. If you have soft ground underneath it, drainage, aggregate drainage is very important. Freezing and thawing, drainage. There's a lot of different reasons why concrete might not last as long as you want it to last. But I think the 407 is, in my opinion, is a great example of a highway that's, in my opinion, is in a great shape, and it was done using the old joint sealing spec.
Sammy, it's Tim here. I think the reason why I believe MTO changed to the single saw cut was because when they were doing the widening the joint to put the backer rod in and then sealing that, there was some issues with the backer rods and some issues with gaps in around them. And what happens, water would get into the joints and they would get joint rot. It would deteriorate the concrete at the bottom where the backer rod is. And so the whole process of going with a single saw cut is to prevent the possibility of that happening. So I believe that's why they did it. Yes, and the 407 was done with the old process and has performed extremely well. But there has been issues with that. And some places actually do not fill the joint. That they believe City of Windsor actually does a single saw cut and they do not fill the joint. MTO requires it, but I can see your issue, but there was a reason behind MTO making that change.
Tim, I have a quick question if there's time. Do you know of any municipality or any specifying bodies that use because the other big reason that they changed the specification on the materials was to help prevent the joint rot, right? That's why we went with the 35 MPa and the slag content in those. Are there any specifying bodies that use an unsealed joint with the new concrete spec, the material spec? Because it's a bit of a belt and suspenders approach, right? We have kind of two solutions for the same problem.
You'd have to ask MTO that question, but I do know in the States there's a lot of areas that have went with doing single saw cut, and to ensure that one way is to minimize the potential of having joint rot is to have some supplementary similar materials in the mix to make the concrete Coulomb rating again lower, which allows for minimizing the penetration of the water into the concrete itself.
I'm just thinking of something to add here. I don't think there's anything wrong of trying to improve the quality of the concrete. Sometimes you have to try different things, and the way I see it is, we tried this narrow joint, and it's a challenge. So I don't know. I think it's beneficial to look at other solutions. I'm not saying it was wrong to try it, but we tried it, and we know that it's very slow, and then the cleaning is a nightmare too. That's another thing. But if you can picture a 6 mil joint, it's just very slow to seal because there's so much fluid you can put in that joint per minute.
And one of the things too with the 407, I just had one of my friends text me that the 407 used actually compression seals. They did not use the liquid hot pour, so they got a very good seal on the joint itself to minimize any potential at all of the water penetrating into the joint. So that's one of the reasons why they have good performing joints in 407.
Okay, that's good. Maybe that's something worth exploring. You know, like different, like, you know, I can't give an answer now whether, you know, the compression seal is going to be better than the 6 mil cut, but, you know, like I think alternatives are, you know, I think it's worth to explore different alternatives right now just because of how difficult that 6 mil cut is to clean and seal.
Sammy, you touched on the cleaning parts. That's one of the questions. How are the joints actually cleaned before sealing? Is that challenging as well?
Well, we had to recut the joints. Let's put it this way. So, like, you know, once, you know, if it's a 6 mil joint and you get gravel in it and you get dirt, like, you know, you do your saw cut, but then you get construction equipment driving. You get all sorts of traffic. You got the shouldering operation, and all that debris goes into the joint. And, you know, from my experience, pressure washing was not enough to get the joint clean. We had to recut the joints, every single one of them. Just put the saw back in it, cut it, and flush it afterwards.
Wow.
And yeah, so it just adds, it adds to the schedule. And then, you know, like in Ottawa, it comes October, it's already cold. And then, you know, like you know, concrete paving projects, you're either, you know, you got to come in, you got to do your grading, you got to do your removals. So a lot of projects are not ready for paving until, you know, July or August. Then you start paving, and you got to be done your sealing before October. Like, you know, that just the logistics of this aspect makes it all the challenging, very challenging. You know, it just you don't have time, pretty much. And the contractors that are available to do it are just very few. So.
Yep, for sure. Lucas, just a quick question for you. Sammy obviously has a lot of challenges on the construction side, but have you seen any, you know, difference in the new specification in terms of trying to produce a good concrete coming from the portable plant?
I mean, the big one is the supplementary cementing materials. I mean, the thing about a portable plant is, you know, you want it to be as small as possible so you can move it as easily as you can, right? Which means you don't have a lot of storage space for cementing materials. So when you add the supplementary cementing materials, so you're using slag, now you got to handle 2 products rather than 1. So, you know, that's using both sides of the silo. That's coordinating with 2 different suppliers, making sure that the flow rates are appropriate and, you know, of material and trucks and everything. So it does add another level of logistical complications. And it slows down the production times too. I mean, that's one more gate that's one more material that's got to get weighed up onto the scale and dumped every load. So it does slow down things a little bit from that side. But at the end of the day, I mean, the test results we saw on this last project were fantastic, and I think it is probably a worthwhile struggle. Mm-hmm. So I think that's probably the biggest one from the new actual concrete paving spec. The aggregate spec's a different beast altogether. I mean, that one's the most recent version is new for most contracts, so I think there's going to be some steep learning curves for some people with that new contract. So I think that's got everybody a little bit timid. So we're going to just be careful as we're producing under that new specification and see how those that specification's enforced.
Yes, because those aggregate penalties are quite hefty. So it's definitely something to consider when you're bidding this type of work. We just got a couple more minutes. So Sammy, one more question for you. Could you please elaborate on how consistency of plastic concrete impacts the edge slump and why it is considered as a key to the success of concrete pavements?
Yeah, well, it's just, you know, wet. If the concrete is wet, we just can't. Well, okay, I'll talk about consistency and I'll talk about slump. So when the concrete is wet, it's just hard to hold the edge. So you need dry concrete. And what happens is, if you get one load that's wet and one load that's dry, just the way the slump is, that could impact ride quality. right? Because wet concrete doesn't place the same way as stiff concrete. So you'd have, like if you can imagine have, like one load showing up wet, one load showing up dry, then the concrete will be wavy, right? It'll dip where the load was wet. It'll be a little bit stiffer and higher where the concrete was dry. So consistency affects ride quality, and you need dry concrete to make the edge stand up the way it's supposed to stand up.
Yep, no, makes sense. And just one final question. I think I know the answer to this one, but I'll let you take it, Sammy. Could the 6 mil joint be cut after grinding instead and then sealed right away? That way you would avoid second cutting and cleaning.
Yeah, I think it could. But the challenge is, let's say we want to recut the joints. Now you can't start sealing after, the spec tells you have to wait 7 days after you place the concrete. So we wait the 7 days. We want to see. You can cut it, but the seal itself, like the amount of fluid that comes out of that nozzle, is just extremely slow. So that on by itself is a challenge, and it adds to the duration. Let's think about different scenarios. Let's say you've put your concrete down, you did your initial cut, say 3 millimeters wide. Then you come in, you did your shouldering operations, and you did your grinding, and now have to recut the joints. Okay, now that recutting is gonna add to the schedule, because now you gotta come in, you gotta recut, you gotta wash, and then you gotta let the joint dry up for a day, and that's the challenge. So you have to recut. You have to get maybe 2 or 3 different concrete cutting crews on site, and don't forget, every recutting crew, you need a water truck. So let's say, like these small logistics make a huge difference. But let's say you're in Ottawa and you need 3 cutting crews and 3 water trucks. Where do you find 3 water trucks? So you need 3 water trucks for your cutting operation. You probably need a water truck for your grinding operation and a water truck for your paving operation. And then all of a sudden, it's just a challenge to get the resources that you need to get the work done on time. Like you want to do it, but then all these small things that come up, and it's just it's just when we have a very short construction period, these are all moving parts that add to the uncertainty. Let's put it this way, and the time. Even if I can guarantee you that everybody's going to show up on time and all the resources are going to be on time, just the fact that you still have to cut the joint a second time, let it dry, and then go on and seal it. And then still you got a groove, right? With a machine, that all adds to the time you need to finish your paving. So it is doable. It's just takes a lot of time to do.
For sure.
Sammy, it's Tim here, but it is critical that you do have to do those initial saw cuts within the 6 to 12 hour time frame. Ensure that you don't get cracks developing in the random cracks developing in the concrete itself. So you can't delay your transfer saw cuts in wait, because you will get concrete will shrink and it will crack if you don't put those saw cuts in at the appropriate timing to ensure that you force the cracks to occur where you want them to occur. So it is critical.
Yes.
It is critical to do those initial saw cuts within the time frame to prevent random cracks developing in the concrete itself.
Oh yeah, 100%. No, we know that it's very it's one of our top priorities. Is not too long to cut the concrete. We always got someone checking. As soon as the concrete is ready to cut, we're on it right away. Yep, it's very important.
Okay.
Great. All right, great. Thank you very much, Lucas. Thank you very much, Sammy and Tim. Another very successful webinar today. Thank you for everyone joining us today. Hopefully you learned something from the contractor's perspective. There are some challenges with the new specification, as you saw from Sammy's overview, but it is a new specification. Hopefully some changes will be made to upcoming contracts. Now, what's next? We are in talks with Amico to do a webinar about open graded drainage layer work that they've done in Windsor and some other locations across Ontario. OGDL is great for the subbase. It really is a stable platform, uniform support for concrete pavements, and it is something that we do want to look at hopefully in our next webinar in April. So again, this is just a tentative date, but we will send out information once we lock everything with Amico. So thank you everyone for joining us. Again, we really appreciate everybody's support when it comes to this webinar series. Thank you to Miller and Tim again for joining us, and have a great day, everyone.
Thanks, Alan. Thanks, Lucas. Thanks, Sammy.
Thanks, Tim.
Take care, everybody.